Alright, so in this video, we're gonna solve a problem which is based on the last topic we have studied, the normalization of the wave function. So this problem is actually taken from the Introduction to Quantum Mechanics by DJ Griffith. This is problem number 1.4, and the solution of this problem will be divided into 5 videos, which actually goes by the 5 parts of the problems. So here we are, first of all, looking at the first part of the problem, which says that I have this given wave function and I need to normalize this wave function. All right, so let's get started. So what I know that for normalization of a wave function, I can write that integral from minus infinity to infinity of the square of the wave function dot dx is equals to 1, right? This is my foundational formula, right? Now, here is the thing. What my wave function says that if I come from infinity to 0, if I just write it like that, if I come from infinity to 0, so my wave function square dot dx plus from 0 to a, then my wave function goes like a into x upon a, obviously squared of that, dot dx. Now further plus from a to b, I have a b minus of x on b minus of a, and I just square this whole part dot dx plus integral from b to infinity wave function square dot dx, and this whole thing goes to 1. Now here's the thing. What my expression shows that the wave function is actually localized between this area from 0 to b, and obviously there are some changes in the wave function. So if I came from infinity to 0, there was nothing in the wave function, there was no area between the wave function and the x-axis, so this part just goes to 0, and here, same here, this part goes to 0. So I'm left with only and only integral 0 to a squared x squared upon a squared dot dx plus integral a to b a squared b minus of x whole squared upon b minus of a whole squared dot dx, and this is equals to 1. So here if I solve this integral, wait, let me write down it as I1. So if I solve I1, it will be simply as a x squared upon a squared dot dx. It will be simply, sorry, it has to be a squared, I'm sorry for that, a squared upon a squared a cubed by 3 if I put the limits and all. So it will be simply like this. So it will be a squared a into 3, right? So this, let me mark it as equation number 1, let me mark it as equation number 2, and now for this integral, let me take this part as I2. Now let's solve for I2. So my I2 is equal to integral from a to b a squared b minus of x whole square upon b minus of a whole square dot dx. So I can take my a squared out, a upon b. Actually, I can take my b minus of a squared also out, but let's just go with it. All right. Yeah. Now I have this thing as b squared plus x squared minus of 2bx upon b minus of a whole squared. So what I'm going to do is I'm going to split the fraction into individual fractions. So it will be simply like a squared integral a to b squared upon b minus of a whole squared plus integral a to b x squared dot dx upon b minus of a whole squared minus of 2 integral bx upon b squared minus of a squared dot dx from a to b. I'm sorry for this part. Right, so my I2 is a squared, and it would be here get a big bracket. It would be b squared on b minus of a whole squared b minus of a, and rest it will be plus. It would be 3 b minus of a whole squared b cube minus of a cube, and then it will be minus of 2 b upon b squared minus of a squared, sorry, b minus of a whole squared, yeah, b minus of a whole squared, b squared minus of a squared, and let me pull off the bracket. Now here, if I have to solve this, if I solve this complex expression, not so complex, but this expression, so I have solved it, and you can solve it on your own as an exercise, and what it comes out to be, what it will come out to be is simply equals to a squared into b squared, yeah, no, sorry, yeah, nah, yeah. So what this whole thing will come out to be as a squared b minus of a upon 3. So let me put it as equation number 3 from 1, 2, and 3. Yes, it would be a squared a upon 3 plus a squared b minus of a upon 3, which is equals to 1. It will go like a upon 3 plus b upon 3 minus of a upon 3 equals to 1 upon a squared. They two just cancel out, which implies that a squared equals to 3 upon b, which again goes like, which implies that a equals to the root of 3 upon b. So here the question solved. I had to find a in terms of a and b. So here it is, my a equals to root of 3 upon b. Hope that you like the video, and wait for the next part. You can watch the next video. Thank you.